So yesterday we spoke about handling missing values, and then we said that we will encode the categorical values, right? We spoke about handling categorical values as well, right? Not handling, but we. So there are three steps, right? We did the first step, that is encoding. Second step is even more important. That is, what do we do now?
Convert. We have to convert it.
Column transform.
Yeah, column
Right?
transform. Yes.
Column transform. So we have to convert into. So column transform, okay, is again a class. Okay. Uh, okay. So we will do it before printing X. So we need column transform. So column transform class is in from sklearn dot compose. Okay, from compose import column transform CNT capital. And the method that you're going to use is called one hot encoding. One hot encoder. Okay, this will give us what we want. Okay, now we need to create an object. Object will take all the required parameters, right? So here we will say transform equal to
Convert transform.
column
Column.
transformer, and then we have to pass the values. Okay, so what values we need to pass? We need to pass values as list. Okay, we have to pass values as list. Okay, so okay, and so here, okay, so it takes two parameters. Okay, one, the required stuff that we need to convert into column transform. Okay, so everything that is required, like we'll pass one hot encoder and method one hot encoding. So this is one value. Okay, we will see what how to pass the values there. And after you are done with that, okay, then we have to say what happens to the other columns, right? We will say remainder equal to pass through. Means remainder, just ignore. Pass through means just pass through them. Okay, don't do anything. Remainder column, just pass through, don't do anything. Okay, that's about remainder. Okay, now we have to pass the required values. And all these values has to go as again tuple. Okay, first thing first. Method, which method are we using? So method we have to say one underscore hot underscore encoder. This is one hot encoder. Then we have to call the function, which is one hot encoder function. Okay, and then which column are we handling? Which column should be handled? What is the column index?
0. Yes.
In this case, 0, right? And
Yes.
it's possible to have 2, 3 columns also. Correct? So we
Yes.
will say list 0. Okay, list 0 because in this case we have only one column. Maybe there could be multiple columns. Okay, so you'll say 0 is a list. You'll say 0, comma 3, comma 8, comma 15, what depending upon the column index, and remainder equal to pass through. That's it. Okay, this is what we need to know. Okay, now okay, we need to transform our X column. We need to transform our X column. So we will say capital X is what we are using so far. Capital X equal to, okay, transform the object name dot transform dot. Okay, so here again, what I said, we have to do fit and transform, right? Here, fit and transform is single function. Single function will do both fit and transform. And you say X. That is it. Now let's run and see what happens. You see this? 1.0, 0.0, 0.0, 0.0. Can you guess which column was this? Which, no, what is the value of region here? East.
Hmm.
East will have first one, right?
Yes, yes. Yes.
So see, you have one here. Okay, and you got converted into four columns: east, north, south, west. Then this is the salesperson, and this is your quotation. Okay, and now we have to delete one column, right? So you simply say x equal to x. Okay, and I will say, okay, I will say column, right? Which column should I use?
First one or last one?
All rows and column from 1 till the end. So now you see, first column is gone, right? I'm saying all rows, column first. So I'm ignoring one. I mean, one means your index one. I mean, index zero is gone, isn't it? So this is how you dropped one column. Any one column you can drop. It's easier to drop the first one. So I drop first one. So this is your categorical value handling. Okay, in this
Hmm.
case, you have to perform column transform on Y also. And because Y is also categorical value, right? You have to perform on Y also. Okay, what is the next step?
Dummy variable.
That is done, right? This is
Yes.
what I did.
Yes, 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 yes.
Next step is fast. Splitting it into train and
Change.
set. Splitting it into training and test set. Okay, so how do you do? So from sklearn dot model selection import train test split. Using train test split, we will split it. Okay. Now this function train test split gives us four values. It returns four different values. Okay. Okay. So we are saying that train test split will give us four values. Which are those four values? These are our X train, okay, then X test, then Y train, and y test. This will simply divide x and y into 4 parts. X into x train and x test, y into y train and y test. Okay, so we have to pass train test split, and here you have to give x value, y value, and how much percentage you want to grade. So that is called test size. Okay, so test size, okay, I want 20%, so I'll say 0.2. I want 30%, I'll say 0.3. I want 25%, so I'll say 0.25. Okay, so here we have, I think, about 10 rows. So 2 rows will be set to test. Okay, 8 will be given to the train. So training will have 8 rows, x train and y train, corresponding values. Okay, it also makes sure the corresponding values are only given in y. Okay, and remaining 2 will be added to your x test and y test. Okay, done. Okay, are we done, or do you think any other step is left here? We need to scale also, right? Scale. And yesterday we discussed why scaling should be done after you are, okay, after you are done with training and test set. Why should we do scaling afterwards? Why should we do scaling afterwards? Yesterday we discussed, right? Yes, no, maybe. Hmm? Nobody's speaking. What happened? Can you hear me, guys?
Yes, yes. Yeah.
So yesterday we discussed, right, why we should do scaling after breaking into trend test and split.
Yes.
We do not want any biasness. So what happens if you
Yes,
do
yes.
scaling before and then if you split, okay, then since scaling is done based on the column values, isn't it? What happens?
Yes.
There will be a trend that is left behind. Okay. So now let me take you to Excel and show you how exactly scaling is done, and then we'll come back and implement. Okay. So I'm going to share my screen on Excel. Okay. So let's say you have age here, right? Or salesperson, right? As per our data, let's have salesperson. And you have here quotation. Okay. Now, salesperson is 2 digits. Okay. So you have like 25, 28, 29, 31, 33, 30, 35, 37, 39, 42, 45. Let's say, okay, these are the values. Okay, now quotation you have values like 56,000, 59,000, 65,000, 67,000, 71,000, 75,000, 79,000, 81,000, 85,000, 90,000. Okay, so let's say these are the values, right? And we said that since these values, okay, are not in same range, okay, the quotation will create more bias into the system. Why? Because the values are simply values are higher. If values are higher, obviously higher values tend to, okay, create biasness, right? Because it's going to hold or put everything towards itself. Okay, so we said that we have to convert them into similar range. Okay, have to convert them into similar range. Okay, so there are two ways to do it. Okay, there are two ways to do it. One method is called mean max normalization. Mean max nor scaling is also called a normalization. Okay, scaling is also called as normalization. If you see the word normalization, it means scaling. Okay, scaling is also called as normalization. So you call scaling or you call normalization. So mean max normalization. And second method is your Z score. Z score normalization. Okay. So Z score normalization uses standard deviation and mean to do it. Your mean max uses mean and maximum value. So the concept is different. In mean max, what it does, it converts this lowest value to 0 and highest value to 1. Okay, the way formula is there, I'll show you the formula later. The way it works is it converts the lowest value to 0 and highest value to 1, and all the other values, okay, will take that ratio between, will be, based on the distance from the minimum value. From 0, it will be, it will be proportionately done. Okay, so all the other values will be between 0 and 1, proportionately done. In that way, the row value is maintained. Okay, if you convert proportionately into, with respect to minimum and maximum value, so the relationship between that column is maintained. Same thing quotation. Okay, uh, so formula here is your x, that is each value, minus mean by denominator is max minus mean. So in this case, you have to figure out maximum value. So let me put this one here. In this case, you need to know maximum value. You need to know minimum value. Okay. So move this one column to the right. Okay. So here maximum value is max of. Okay. You go and do this, and this is going to be maximum value of this. No, this is mean, right? Sorry. Okay, if I control C and control V, I'll get minimum value, maximum value there. This is minimum, the mean of this, and I'll copy and paste this here. This becomes minimum value. So I got minimum value, maximum value. Each of these value, okay, so we say normalized salesperson becomes, okay, X minus mean value divided by max minus mean. Denominator is fixed. Denominator is difference between max and mean. Okay. So with respect to difference between max and mean, these values are getting scaled. So I'm going to say x minus mean divided by max minus mean. Okay, done. So see, minimum value will become 0 because mean minus mean, B2 is minimum, right? So it becomes 0, irrespective of what is in the denominator. I'm going to fix the other three values here. Okay, before I fix it, what I'll do is, because I need to do it for this one also, right? Quotation. So I'm going to move this around. So this becomes your norm sales quotation, right? Quotation. Okay, now you fix it. Fix what the minimum. So F4, F4, and F4. Then here you say F4, F4, and F4. Done. Now just double click on it and double click on it. Okay. So see, minimum value became 0, maximum became 1, and all the other values are within max and mean. Okay, so within the range. Okay, so this is how you perform what is called as mean max normalization. This is your mean max normalization. But what is most used is called Z-score normalization. Here we use standard deviation and mean. So we have to calculate mean and standard deviation. Okay, most of the values will be between 3 sigma, 3 standard deviation. Okay, so you will see most of the values will be between -3 and 3. There will be some values more than that also. Okay, more, less than half percent values. Okay, 0.3% values will be more than -3 and 3. But most of the values will be within 3 sigma. So mean, how do you calculate? You calculate by average, AVG, or average, type completely average, and then you do this. Okay, so this is average here, and same way you can calculate average for other column also. Standard deviation is STD, DEV, and this is for population. We have all the data. Okay, so we will use standard deviation population here, and then you say, so this is your standard deviation 6.1, and 10,000 is just standard deviation there. Okay, so what we do here, okay, here norm sales, and here will be norm quotation. This is based on your Z-score normalization. Z-score normalization is, okay, let me write the formula here. The formula is x minus mean divided by max minus mean. Okay, so what happens when x is minimum? Minimum minus minimum will be 0, right? Minimum minus minimum will be 0. So for mean, we get 0 value. If it is max, x is max, then numerator and denominator becomes same, right? Max minus mean divided by max minus mean. So it becomes 1. And everything else will be between 0 and 1. That is your mean max normalization. In Z-score, we say x minus mean value divided by standard deviation. Okay, this is the formula to normalize your value. So if I go here, say equal to bracket x minus mean divided by standard deviation, right? Minus 1.5. Okay, now you have to, I'll fix this, right? I will make this constant. So F4, this becomes, this is also your F4. Then this is your F4. This is your F4. Okay. Now just drag it. Okay, so this is how you scale value. Now you see they are in similar range, right? They are in similar range. Okay, this is how we perform scaling, or you can also call it as normalization. All right, so let's quickly move on to our code and let's try to perform scaling here. The splitting is, I call it as step 3, right? And then step 4 is scaling. Scaling slash normalization. Okay. So now I'm going to call from sklearn dot pre-processing import standard scalar. Now standard scalar will perform using your z scalar. Okay. So the function, the class. Okay, the class that is your standard scalar class performs scaling using z scaling. Okay, so here, okay, I mean, that's the default one that we are going to do. So I'm going to say scale norm equal to, okay, standard scalar. Okay, and we will give default values to it. Okay, we'll give default values to it. Now, we need to scale both x train and x test, right? So x train equal to scale dot fit and transform both. What x train? X test equal to scale dot fit transform x test. That you're ready to now perform the model building. Yes, these are the pre-processing. These are the steps that you have to do. Missing value, categorical value, and scaling, and then of course train test and test set. Train test and set we have to do always, because that's how we are going to measure the performance of our model. With me?
Yes.
Okay, so yes. Okay, uh, as I told you, okay, always, okay, you go to pre-processing steps. Okay, sorry, what I'm saying, you goes to, okay, I'll show you. Yesterday I showed you. You should go to sklearn scikit-learn.org and get into this. Now you can type here. Let's say we did, what is the last thing that we did? We did scaling, right? Standard scaling. You type standard scaling. Okay. So what was that? Sklearn dot pre-processing, right? So go
Yes.
to pre-processing dot scale. Okay. And okay, so I'm talking about getting more information. Okay, pre-processing data, imputing missing values data, right? All the other things also we'll discuss step by step. For now, you should get into pre-processing data. Okay, now you see here standardization or mean removal and variance scaling. Okay, so you see standardization is of data set is a common requirement for many machine learning estimator implemented in scikit-learn. They might behave badly if the individual features do not more or less look standard, normally distributed data, Gaussian with zero mean and unit variance. In practice, we often ignore the shape of the distribution. So read that, and this is an example here. You see standard scalar. We are using standard scalar. Okay, standard scalar is your I told you. Okay, standard scalar is Z scalar. Okay, these are the models. Okay, so don't run that. These we'll see from next week. Okay, okay. So this is if you want to apply min max. Okay, you can apply min max scalar. So pre-processing dot min max scalar. Min max scalar. Okay, so if I go back, okay, did I not print it? No, I think I have not printed, right? Let's go back to here. So you print X train now. So see, all these values got changed. Now, see, these values also got changed, right? We don't want to change these values. Which values? These zeros. So here you will say X train, okay, X train, okay. Now, X train here, you will say all rows, okay, but column, which one? Okay, which column do you want to see here also it doesn't matter because see all are only two values, right? You'll have like 0 became minus 0.6 and 1 became 1.6, right? So it doesn't matter, but logically we should say all rows 0, 1, 2. 0, 1, 2 are your region column. So we have to say from 3 till the end, right? 0, 1, 2 are your 0, 1, 2 are your region column, right?
Yes.
So we okay if you do not want to scale region, but if you scale region also it's fine here. Okay, doesn't matter, but logically we should not scale it, right? So same thing here. Okay, and this is going to scale only your specific values. Okay, let's go back to our yes. In case you want to do min max, you can of course you can use min max. See, this fellow has used min max here. So instead of standard scalar, use min max scalar, and it will change the value between 0 and 1. Okay, you will have 0, you will have 1, and all the other values will be between zeros and 1. Okay, then you have other like you have max absolute scalar. Max absolute scalar. Okay, so in min max we are doing 0 and 1. In max absolute scalar it will be minus 1 and 1. Okay, so minimum value will be minus 1, maximum value will be 1, and your mean value will be 0. That's how it is designed. Okay, and this is the formula. You can see the formula. Okay, when there is a sparse matrix, very few data. Okay, so yeah. So this is how you have to go and learn about each of the concepts. So we discussed about pre-processing, standards. I mean, scaling we discussed, column transform. Again, you have to go to column transform here. Okay, three things you have to do. What? Column transform, standard scalar, and impute. Okay, go here and type column. Okay, column transformer. Okay, so now you see compose column transformer, right? Click on column transformer here. Now you see the first one is list of tuples. That's what we added, list of tuples. In list of tuples, we added, okay. Now see here, Transformer second value, okay, we said pass through, that means ignore, leave it. Or you could have said drop, that means drop those columns. So if I had used dropped, the quotation and salesperson, the last two columns would have been dropped. Okay. So in our case, we don't need to drop, but in some cases you might have to drop. So you'll pass values there as drop, remainder. Okay. Yeah. These are the values. Okay. And it'll tell you about the importance of all the values. Okay. It gives you smaller example also. Okay. So you can practice and see what happens. Fit all transform using it. Fit transform, fit all transformer and also transform. So this is how you get the data. Okay. Did you understand? So like that, you have to go through and spend some time trying to understand, practice, okay, and you will understand more about those functions. All right. So I think we are done with pre-processing. We'll stop here for today. And in the next session, when we meet, that is on Monday, we will start with our first algorithm. Okay. We will learn to develop our first algorithm, that is the regression algorithm. All right.
Yes.
Any question before we stop?